Alright, what's popping, guys? So welcome back. Today we'll be doing question 23. Merge K sorted list. It's a hard question, but it's actually not really that hard, not as hard as compared to other hard questions. So we're given an array of K linked list, and each linked list is sorted in ascending order. So all we want to do is merge all the linked lists into one big final sorted linked list and return it. So we actually have done a similar question before. It's called merge two sorted linked lists, where they just give us two sorted linked lists and they want us to merge it together. So that one was, I think, a medium question, and we managed to do it, right? So this time all they did was they want to expand it to a general K linked list. So let's come back. Let's come to the example. So imagine they gave us an array of however linked list there is, right? That could be like 5 or 6 or however K linked list. Basically, they want us to take each linked list, take all the linked lists, and basically merge it into a final big linked list, and then return it. So they already told us that each individual linked lists are already sorted. So actually, it's very similar to the merge two sorted linked list questions. So if you look at this example, so they give us a big input array, linked list. So they have 3 linked lists within it. So the first linked list is 145, which is sorted. The second linked list is also sorted 134, and the last linked list is also finally sorted 2 and 6. And basically they just want to output it to be like this: 1 1 2 3 4 4 4 5 6, which is the elements from all these 3 linked lists, right? So we just merge it together. Okay, so it's actually a really simple question once you know how to merge two sorted linked lists. So let me explain how we can do it. So actually it's just like merge sort. So if you are not familiar with merge sort, basically what we're doing is we're gonna be basically merging. We're gonna be taking 2 linked lists at a time and merging it. So we're gonna take the first 2 linked lists, we're gonna merge it, right? So we're gonna merge it and we're gonna call it LA. So this linked list A will be a merge between L1 and L2, right? So the process of merging 2 linked lists, we are already familiar. So that one is easy. So then we're gonna take the second 2 set of linked lists, we're gonna merge it, and we're gonna call this linked list B, right? And then all we're gonna do is we're gonna keep repeating it. So we're gonna merge. Finally, we're gonna merge the 2 sorted linked lists here, and then we're gonna merge it into the final linked list, like this. So we're gonna see that the operation here is gonna be log base 2 of n, where n is not n, it should be k, where k is the number of linked lists, right? So because we are basically merging, we're gonna be halving the linked list, halving the number of lists that we need to merge each level down, right? So imagine if k, initially we have, let's say 8 linked list to be sorted, right? If you merge 2 by 2, we're gonna come down, right? If you come down, the second level will only need to merge 4 linked lists, and then we're gonna come down again, we're gonna merge 2 linked lists, and finally we're gonna just end up with 1. So you can see that the level, there's gonna be 3 levels here, which equals to log base of 8. So this log base 2 of 8 equals to 3, right? Because we're cutting down the amount of linked lists that we need to merge by 2 every time. So that's the time complexity. And then the merging of each linked list will take O of n, right? Where n is the O of n, where n is like a plus b, the length of linked list 1 plus linked list 2. So the final capacity, the final algorithm is gonna be n log k, n log base 2k, right? So that's good. So all we need to do is understand that we're gonna basically keep merging. So we're gonna take 2 at a time, we're gonna merge it, 2 at a time, we're gonna merge it, then we're gonna keep repeating it until we're finally left with 1 linked list within the array. So let's code here and then we'll see what we mean. So we're gonna check if not list, just a base case, just some exceptions, right? So some edge cases, if not list or the length of the list equals to 0, right? So there's no linked list within the input array. We're just gonna return none. Okay, then now we can actually start coding. So we're gonna do while the length of list is greater than 1. So the length of list, so this list variable is gonna hold all our merged linked list. So as we merge it down, so at first the list variable, right, is gonna hold 4 linked lists, right? Then on the next iteration, the list variable will only hold 2 linked lists, and finally the list variable after merging everything will only hold 1, right? So that's why we're checking while the length of list equals to 1, we want to keep merging 2 by 2. Okay, so we're gonna basically have a temporary variable called merged list, which is gonna hold an empty array. So this merged list is gonna hold the temporary list for the current level, right? So after that, basically we're gonna merge this 4 array, and then the merged list we're gonna just contain this 2, and then we'll set list to the merged list. Okay, so we'll have the empty, and then we'll do for I. So now we're gonna break it into pairs, right? So for I in range 0 up to the length of the current list, and we want to skip by 2 each time, right? So let's say at first k equals to 4, right? So the length of the list is gonna be 4, right? So for I in range of 0 to 4, so we're gonna be going from 0, 1, 2, and 3, because it's not including the final endpoint, and then we'll skip by 2. So what is gonna, this I variable is gonna give us 0 and 2 only, right? Because we're skipping by 2 each time. So 0 first, then we'll skip by 2 out to 2, then we reach the end here. So for I in range of 2, so now we have the index of 0 and 2. How can we split into pairs? So this 0 will represent the first item here. This index 2 will represent 0, 1, 2, the second pair. So we're gonna take these 2 pairs and then merge it together. Okay, but what if it's a odd number? So let's say a list, right? There's an L5 here. There's an L5. So we'll have 0, 1, 2, 3, 4, right? And then if we do it by 2, it's gonna be 0, then 2, then 4, right? So if there's a L5 here, we're gonna just take this pair here where there's a null value here, right? And we can merge L5 and null, because if you're doing the L5 and null, we can just return L5 because it's already merged. So we just have to consider this edge case here. So we'll take L1 to be list at index I, and then L2, so the second pair, the second item within the pair will be list I plus 1, right? So we'll take only list I plus 1 if I plus 1 does not equal to the length of list, right? Because if it equals to, then it's out of bounds, right? Else is none. So this is only to take care in terms of if it's odd number, then the last element will be out of bounds. Then lastly, we'll do merge a list, right? So we take this temp merge list. We want to append the result of doing self dot merge to list. We're taking in L1 and L2. So this function, we're gonna be writing it after it. So we're gonna have a function within the class will be called merge to list, right? We're taking self L1 and L2. So it takes in 2 linked lists, and this function will merge 2 sorted linked lists. So which we have already done. So I'm gonna write the function later. So we'll just assume that this function works now. So after merging it together, right, after merging all the pairs together, we just want to set the list variable to the merged list. So this will basically complete one level of the merging. Then we'll keep continuing until at the end. So once we exit out of this loop, we know that the list variable will contain the final merged linked list, and then we can just return list at index 0. Okay, so now let's implement the merge to list. So we have already done this before, so I'll just go a little faster. So we're gonna have a dummy variable called list node, right? So this code has been written, I've explained it thoroughly in a previous video before. So then we can put a tail as a dummy. Then while list 1 and list 2, right, if L1.val is less than L2.val, right, we're gonna set tail.next equals to L1, and then L1 will be set to L1.next. Else tail.next equals to L2, then L2 equals to L2.next, and then finally out of here we'll do set tail equals to tail.next. Then at the end we just want to check in case L1 or L2 still exists, right? There's still remaining nodes within it. So if L1 tail.next equals to the whole remaining of L1, if L2, we'll set the tail.next equals to the whole of remaining of L2. Then at the end we just want to return dummy.next. So let's try running this. So if everything goes well, we should be able to run it successfully, and it works. So you can see it beats 63.85%, right? So this will obviously run in O of n log base 2k. So it's a logarithmic solution, right? So I hope you understand. It's not that hard once you understand, if you have the basics of merge sort and you understand how to merge 2 sorted linked lists with this small function here. So if you found the video helpful, please like, comment and subscribe, and other than that, have a good day. Thanks so much.